Hello students, today we're going to learn section 5.1 Fundamental Identities. We have to recall basic trig identities on page 445 and 446, so please review that. And a couple of Pythagorean identities is cosine squared theta plus sine squared theta equals 1 plus tangent squared theta equals secant squared theta, and cotangent squared theta plus 1 equals cosecant squared theta. Example 1a wants us to find sine theta and cosine theta if tangent theta is equal to 5 and cosine theta is greater than 0. So we have to remember that tangent theta is equivalent to y over x, so therefore y is 5, x is 1. Tangent theta we know is positive in the first and third quadrant, and cosine theta is greater than 0, meaning positive in the first and the fourth quadrant. So that means our main focus is in quadrant 1. Remember, all students take calculus. Okay. So now we just have to find r, and we did that in the last chapter. We know that x squared plus y squared equals r squared. Therefore, r is equal to the square root of 26. We're only going to keep the positive square root of 26 because r is considered a distance. So now we just find sine theta. So sine theta is y over r. Well, y is 5 and r is square root of 26. Cosine theta is x over r, and x we know is 1 over radical 26. So that is example 1a. Example 1b. Find sine theta and tangent theta if cosine theta is 8/10 and tangent theta is less than 0. Well, 8/10 is rewritten as a ratio. So this is 8/10, this is 8/10. I reduce 8/10 to 4/5. So we know x is 4, r is 5. Therefore, we're going to use the Pythagorean theorem again to find y. Y is equal to -3. The reason why y is equal to -3 because cosine is positive in the first and the fourth quadrant. Tangent is less than 0 in the second and fourth quadrant. When we say tangent less than 0, that means tangent is negative. So that means our focus is going to be in the fourth quadrant. Again, if you want to write this down, all students take calculus. It will remind you which trig functions are positive in which quadrant. So again, sine theta is y over r. Y is -3, r is 5. And we know the y values in the fourth quadrant are negative. Tangent theta is y over x. Therefore, we have -3 over 4. So that is example 1b. Okay, just some more functions to recall. Just write these cofunction identities down. So we know that when we take the sine of the quantity pi over 2 minus theta, it's equal to cosine theta. These are identities. So just copy these 6 identities down, and we're going to use them for the next example. We also have odd-even identities. When we take sine of a negative value and you get the exact opposite, this is odd. Right, this is odd. This is odd because tangent of a negative value is equal to the exact opposite. Cosine of a negative value is equal to the exact opposite, so these are all odd. And these two are even. They're even because cosine of a negative value gets you the exact original function of cosine x. Alright, example 2a. If cosine theta equals 0.34, find sine of the quantity theta minus pi over 2. Well, we're going to start off with that. But if you notice, I don't have sine theta pi minus 2 here. I have sine pi over 2 minus theta. We switched it. So in order to look for this, I'm going to factor out a negative so I can rewrite it as pi over 2 minus theta. So that's what I did from here to here. This is exactly the same value of this. I just rewrote it. I factored a negative out. So when we take a negative out, this negative becomes positive, this positive becomes negative. Well, if I take this negative out and put it in the front, I have negative sine of the quantity pi over 2 minus theta. Well, that means that this part here, sine of pi over 2 minus theta, is equal to cosine theta. Brought down the cosine theta, brought down the negative. So we have negative cosine theta. Well, that's what we want to find, cosine theta. So we substitute cosine theta, 0.34 for cosine theta. So there's your answer. Example 2b. If cotangent of negative theta equals 7.89, find tangent of theta minus pi over 2. So we start off with what they want us to find. And again, I do not have a theta minus pi over 2. I have a tangent pi over 2 minus theta. So I need to rewrite this. I need to put the pi over 2 here and the theta here. So once you switch it, you factor out a negative. So we have tangent of negative pi over 2 minus theta. So this here is equivalent to the previous line. Put the negative out in front. So we have negative tangent of pi over 2 minus theta. Well, tangent pi over 2 minus theta is cotangent theta. So that's what I wrote down, cotangent theta. Well, I know this is an identity here. If you look at this, it's right here. Negative cotangent x equals cotangent of negative x. So negative cotangent theta is going to equal cotangent of negative theta. Well, we already know what cotangent of negative theta is. It's 7.89. So tangent of theta minus pi over 2 is 7.89. Okay, so again, this negative cotangent theta is right here. It equals cotangent of negative x. So I just substituted, and we already know what this is because it was given to us. So that's example 2. Example 3. Simplify. When you see the word simplify, reduce it to one term if possible. So secant x plus 1 times the quantity secant x minus 1 over sine squared x. When you multiply these two, this is the sum times the difference of the same two values. So we get a difference of 2 squares, secant squared x minus 1. Next, secant squared x minus 1 is equal to tangent squared x. Remember, it was a Pythagorean identity. So right here, secant squared theta, if you put minus 1, you get tangent squared theta. So that's where that comes in. So secant squared theta minus 1 is tangent squared x. All right, over sine squared x. Well, secant squared x minus 1 is tangent squared x over sine squared x. I'm going to rewrite this as, this means division, so I'm going to write it horizontally. Tangent squared x divided by sine squared x. change division to multiplication, take the reciprocal from elementary school when you divide fractions. We know tangent squared is equivalent to sine squared over cosine squared. These sine squareds reduce to 1. We just have 1 over cosine squared x, and 1 over cosine squared x is secant squared x. So that's example 3. And again, this here came from our identity. It was this here. 1 plus tangent squared theta equals secant squared theta. Well, if I subtract 1 from both sides, we get tangent squared theta equals secant squared theta minus 1. That's where I did this substitution from here to here. Okay. Example 4, simplify again. We have sine cube x plus sine x cosine squared x. So what we're going to do is we are going to, factor a GCF. So we have sine x in both. So we have sine x times sine squared x times cosine squared x. It is equivalent to the previous line. So when you distribute sine x to this term and this term, we get the previous line. Well, this is a Pythagorean identity. I know sine squared x plus cosine squared x is equal to 1. 1 times sine x is sine x. So when we simplified it, we reduced it to one term. Example 5. Okay, now we have fractions. Well, what I'm going to do when I see something like this, I'm going to multiply by the conjugate. So when I multiply by the conjugate, it's 1 plus sine x times 1 plus sine x. The reason why I'm doing that is because now this is going to be a difference of two squares. So we have cosine x times the quantity 1 plus sine x over 1 minus sine squared x. 1 minus sine squared x is equivalent to cosine squared x. So I'm just working with the denominator. I bring this other part of the expression down. Well, if you notice, cosine x over cosine squared x reduces to 1 over cosine x. Now we have a common denominator. That means we can move the two numerators, we can combine them. So we have 1 plus sine x minus sine x. These two will add up to 0. We have 1 over cosine x, and 1 over cosine x is secant x. So we simplified examples 3, 4, and 5. Example 6 and 7 we have to solve. Now when we solve trig functions, since trig functions are waves and they continue, we'll have an infinite number of solutions. So I just want to focus on solutions from 0 to 2 pi. So when we solve, we just want answers between 0 and 2 pi. Okay, so here is our first equation. We're going to solve for x. I'm going to factor cosine cubed as cosine squared times cosine over sine x. This expression is equal to this expression. I notice that cosine x over sine x, that's going to be cotangent x. So cosine x over sine x is cotangent x. I'm going to subtract cotangent x from both sides of the equal sign. And now, once we do that, I can factor. There's a GCF here. The GCF is cotangent x. So once you factor out cotangent x, take the GCF, we have cosine squared x minus 1 left. This is from the Pythagorean identities. Cosine squared x minus 1 is equal to, since it's factored, we could set each factor equal to 0. So cotangent x equals 0. So again, from chapter 4, what you're asking yourself is, cotangent of what angle gets us 0? It's pi over 2 and any multiples of pi over 2. But since our answers are restricted from 0 to 2 pi, these are the two answers that we can use. We'll take the next factor, set this equal to 0, add 1, cosine squared x equals 1, cosine x equals plus or minus 1. So for cosine x, Cosine of what angle gets you positive 1? It's going to be 0 and 2 pi. And cosine of pi will get us negative 1. But when I substitute these numbers back into x, cotangent of 0, if you check, it's undefined. Cotangent of pi is undefined. If I put a 0 here, sine of 0, that's also undefined as well. So these are called extraneous solutions. If you substitute these values in, they will work for both sides of the equal sign. Example 7, again, solve. I notice we have a quadratic linear term and errors are constant. Well, subtract 1 from both sides. Here's our quadratic trinomial. We'll factor 2 sine x minus 1 times the quantity sine x plus 1. Set each factor equal to 0. Add 1 to both sides, divide by 2. So now you're asking yourself, sine of what angle gets us 1/2? That's pi over 6 and 5 pi over 6 if you look at your chart. You should know it by now. Take the next factor, set it equal to 0, subtract 1. Sine of what angle gets us negative 1? Well, it's 3 pi over 2. And all of these solutions are valid for these x values. You will not get undefined anywhere. All right, that's it for today. Have a good day.